Alright guys, so you're ready for part 2 of the video. We just went over solving quadratic inequalities and we did example 1. Just want to remind you of your steps. Step 1. Determine the solutions using your quadratic formula. Step 2. Plot these points on a number line. Step 3. Pick one point on the left, one in the middle, and one on the right of these points. And finally, you're going to test each region by plugging into the quadratic inequality. If you find out that you get a true statement, that means this is part of the solution and you need to shade on either the left, the middle, or the right, wherever that point was. If you get a false statement, that means this region is not part of the solution and you do not shade. So when you ended part 1 of the video, I told you to try example 2. So hopefully you've tried example 2 by now. We're going to work this out. Example 2, when you look carefully at it, you see that you have a less than symbol. Less than should remind you that you're going to have open circles when you put this on your number line. But in the meantime, you need to figure out what are those two important x values that you need to find. And you're going to do that by doing the quadratic formula. In order to use the quadratic formula, you've got to know a, b, and c. You don't know those yet. You've got to get this 11x to move to the other side. So you're going to use the inverse operation. The inverse of a positive 11x is a negative 11x. You've got to get it in the right place also. X goes right in between the x squared term and the constant term. So what you end up with is 10x squared minus 11x minus 35 less than 0. I'm sorry that my hand makes it go white, but it is what it is. So your a value. A is always in front of x squared. B and C. A is 10, B is negative 11, C is negative 35. So we're ready to put into our quadratic formula. Negative B plus or minus the square root of B squared minus 4AC all over 2A, which is 10. In order to find this, I'm going to use my calculator, and I plug into my calculator. When I plug into my calculator, I find I get 5 over 2, and I get negative 7 over 5. And those are fractions. Fractions are okay. You can get fractions. But I find I have a little problem with those. I can't tell sometimes exactly where a fraction should be on a number line. So I'm going to turn these into decimals. Now hopefully you know a little something about these numbers, but just in case you didn't, in case you had some strange fractions, I want you to take your calculator. 5 over 2. There's several ways to turn this into a decimal. You could do 5 divided by 2. You get 2.5. You could use your N over D button, hit enter. Well, that gives you 5 over 2. That doesn't help you. But remember that we have this little button down here. When I push that, it gives me 2.5. So the decimal value is 2.5. I understand that 2.5 is halfway between 2 and 3. So I'm going to do the same thing with negative 7 over 5. We'll type negative 7 divided by 5. I find out that that's a negative 1.4. So I have completed step 1 here. I'm going to plot these on my number line. And I'm going to do a little bit better job this time of trying to balance this number line out so that I can write my left, my middle, and my right on my work kind of organized for you. So I've got to be between 2.5 and negative 1.4. Well, 0 is the best place to start. 0's in between. To get to 2.5, I'm going to do 1, 2, 3, 4. This is 2. This is 3. 2.5, it's halfway in between. But before I put a dot, I need to go back to my inequality symbol. I have a less than. That means I have an open circle at 2.5. Now I'm going to plot the other point. I go to -1, -2, -3. -1.4 is, you go all the way to -1, not quite halfway. You put an open circle again because you have just a less than. There is no or equal to. So my circles represent the important parts. Those are actually, if you were to take a graphing calculator of some sort and you were to graph your function, your quadratic function, these would be your x-intercepts. Remember, that's what solutions are. Now it's time for me to figure out where do I shade. I'm going to pick a point on the left, the middle, and the right. So I'm going to label those. This is the left side. This is the middle. And this is the right side of my graph. Remember, I can pick any point I want to over here. I pick x equals -2. Why? Because I want to. It's on the left, so I can pick it. For the middle, I bet you can't guess, I'm going to pick x equals 0. I could pick 1. Remember, I could pick 2. I could pick 1.2. As long as it's in the middle of these 2 points. And for the right, I'm going to pick x equals 3. Now, I take my number, I plug it back into this original. I technically could plug it into the original or the one that I manipulated a little bit to use the quadratic formula. As long as I did it right, I'm going to get the right answer. Now, I'm going to plug it back into the original for the sake of you understanding and seeing. So I'm going to take 10x squared minus 35 less than 11 times x. What x did I pick? For the right, for the left, I picked -2. So I'm going to plug in -2. I know this right side, 11 times -2 is -22. I'm going to take my calculator and I'm going to plug that in. I'm going to say 2 parentheses -2 squared minus 35. If you notice, what's on my calculator screen looks identical to what's on your paper. Hit enter, you've got 5. Now you need to ask yourself, is it true that 5 is less than -22? The answer is no. That's false. 5 is much bigger than -22. So this is false. And what does that mean? That means you do not shade on the left side. So no shading. Now I'm going to try the middle. I'm going to draw a little squiggle just to separate. I'm going to plug in 0, the same place I plugged it in before, plugging it into my original. So I take 10x squared minus 35 less than 11 times my x. My x is 0. Now you should be able to do this. 0 squared is 0. Times 10 is 0. And 0 minus 35 is -35. But again, if you struggle with that, plug it in your calculator to make sure you are correct. And 11 times 0 is 0. So then now you need to ask yourself the following question. Is it true that -35 is less than 0? Yes, it is. This is true. So what does that mean? That means you shade here. And where is it? It's in the middle. So I know I'm going to shade in the middle of these 2 points because that's where 0 is located. Since 0 is in the middle, I shade in the middle. Now I'm going to test my point on the right. just to make sure that I didn't mess up somewhere. So I plug in. I say 10, 3 squared minus 35 less than 11 times 3. 11 times 3, that's 33. I got that real easy. Plug the rest in. Now, if you got a little calculator skill here, I'm trying to plug in into the same equation. I just need to change a -2 to a 3. So I use my up button. I highlight the equation I want to mess with. I hit enter. Now I can go in here and turn this -2 into a +3. Hit enter, 55. So I've got this statement. This statement says that 55 is less than 33. Is that true or false? That's false. So what does that mean? That means you don't shade here. So you've done all this work. You've shaded correctly. You have found that your answers are all of these numbers in between -1.4 and 2.5. But with all the work you've got here, you would have the wrong answer because you don't have an answer. You have to write your answer as an inequality. So look where you shaded. Those are your X's. Is your shading to the left, in the middle, or to the right? Your shading is in the middle. It is trapped between -1.4 and 2.5. Therefore, your X's are between -1.4 and 2.5. Now, we use less thans. We know that. I've told you that. But you may not understand why. Here's why. Look at it from this point of view. These are your X's. These X's are less than 2.5. This is -1.4. -1.4 is less than all my X's. So what I'm saying is -1.4 is less than my X's, and my X's are less than 2.5. Now you may be thinking, why didn't she use or equal to? I did not use or equal to because I have open circles. Well, why do I have open circles? Because my very first inequality was just a less than. For that reason, I don't have open circles. So I have all this work, and the answer that I'm looking for is right here. I'm looking for you to describe to me the X's that make this inequality true. What I want you to do now is I want you to pause this video and I want you to do example 3. I'm going to work example 3 out, and I'm going to show you the answer, and I'm going to show you the work. But I'm not going to explain it in the video, and to be honest, it's just because I don't have time left in my recording time. Alright, so I have just a few more seconds left in my video, and what you see here is the completed example 3. I want you to notice something really quick. So I did my quadratic formula. These numbers go on the number line. I picked my numbers 0, 1, 5 based on the fact that they were left, middle, and right. But when I plugged in, I did not plug into the original. I want you to think about what you know about Miss Lusher for a minute. I work smarter, not harder. Look at all these X's. I don't want to plug in everywhere. This expression is equivalent to this one. I plugged into the one that looked easier. And when I did, this is my final answer. So I want you to make sure that you have all of these notes down, and these notes had better be in your notebook when I see you next time. Have a wonderful weekend, and I'll see you soon.